again, welcome to all of those who have joined or are still joining. This is our Autodesk Community Conversations. Again, this is the Dynamo Office Hours one. Basically, if you are new to this, Community Conversations is a way for us to get you connected with expert speakers from not only the Autodesk community, but also people who are employees at Autodesk, which we have today. And really, it's just about them sharing their knowledge and making connections and things like that. So yeah, that's kind of what this is about. This is just our safe harbor statement. Basically, this very long paragraph or 4 says that anything that we talk about today, if they make any future looking statements and things like that, just don't want it basically influence your purchasing decisions and things like that. So you guys can just take a quick read.
Cool. So we do have a special guest this week. We'll do our introductions. My name is Jacob Small. I'm an Autodesk implementation consultant based out of Stockholm, Sweden. I would describe myself as a Dynamo forum junkie. You will see me on the forum all hours, even when I probably should have been joining, I don't know, a community conversation Zoom meeting instead of composing a reply. But yeah, that's me in a nutshell. Sol.
Hey everyone, my name is Sol. I'm a product manager working on Dynamo. I describe myself as a curious human being, and today I'm along for the ride because Jacob and Guillermo are doing all the heavy lifting. So over to you, Guillermo.
And I'm Guillermo Melatoni. I'm product manager on Autodesk. Started with AutoCAD back in the day, and now I'm the head of Tinkercad for the last 10 years, and also work on Fusion. But today we're talking Tinkercad, so I just added that one there. And lots of guitars in my life, as you can see, with all sorts of strings. Anyway.
Nice. All right, so today's session is tinkering with interoperability. It is all about interoperability within the context of Dynamo. We'll get into some of the specifics in terms of what we mean by that and get an introduction to Tinkercad and sort of how we built a quick interoperability tool between Dynamo and Tinkercad. So as always, the conversation is going to be structured this way. We're going to have a brief presentation on tinkering with interoperability. Then we're going to go into a live demo where I'm going to open up my interoperability graph and we're going to look at sort of moving stuff back and forth. And then we'll have our question and answer stuff time at the end. So without further ado, let's talk about design to start with. So design really is an art form, right? And it doesn't really sort of happen in a vacuum. It's not something that you do in isolation. There's a lot of people involved and a lot of tools as well. You can imagine if you were going to hire, I don't know, a famous painter, Da Vinci. We go back in time and we hire Da Vinci. We're not going to give him one paintbrush and say, go ahead and do the entire Sistine Chapel ceiling with this. No, we are going to make sure that he's got all the paintbrushes he might desire to get the best possible results. And digital design is no different. So we've got integrations for Revit, Civil 3D, Format, Alias, Robot, Advanced Steel, and all sorts of other stuff, primarily in the Autodesk architecture, engineering, construction collection sort of space, right? But it's possible to get into some other stuff as well. So what sort of other paintbrushes might be available for Dynamo? Well, we've got beyond those, we've got our import-export workflows where we can sort of bring in SAT file, SAB files, right? Standing for standard ACIS text or standard ACIS binary. You can get some information on those file formats at Paul Bork's excellent website. If anybody's getting into computational design, I recommend spending a lot of time on his pages because it gets into all the nitty-gritty on those other formats. You could also use solid defs, which is an internal Autodesk format that basically produces a string for various types of geometry so that you can bring stuff out of your Dynamo graph into an external file and then into another Dynamo graph as well. There's also data remember nodes and stuff like that. But even with all that, it's not going to quite give us all the goodies that we're really after, right? We've only got a couple brushes there. Now, for anybody who's curious, these are the import and export nodes for SAT, SAB files. You can see export to SAT with or without the units, import from SAT with units, and deserialize from SAB with units, all available in Dynamo 2.18. I believe these were all added. It might be 1.7 though, so feel free to correct me if I'm wrong. Oh, we've got another person coming in. There we go. Then our solid def nodes are here again in our geometry modifier section. There's the geometry dot to SolidDef and geometry dot from SolidDef. Those are, again, going to sort of produce a string representation of the geometry that is stable between the two different parts and pieces. All right, so what if we wanted sort of a little bit more than just those? Well, let's look at interoperability with Tinkercad. So we're going to take one particular brush out of that paint sort of list of all possible paintbrushes and see what we can really do with it. But before we get there, we've got to learn a little bit about Tinkercad. So Guillermo, why don't you take it away?
I'm probably Tinker will be the kind of the thickest brush from the right, because it's so general, right? So, and some of you might be wondering, what the hell is Tinkercad? Some of you might be wondering, hey, my kids use Tinkercad, and some might say, why would we care, right? So let me just try to get some answers for all of that. And we're kind of a little thing there in Autodesk, but we're pretty big too, right? So we just reached 65 million users. That means around 5.7 monthly, and yeah, that's a good one, right? So just for the sake of scale, that means all of California and all of Texas population together, which are the two largest states in the US, or France, right? 5.7 million monthly active users on peaks, and we normally means when both northern and southern hemisphere are in classes. So we're just now going down because of the summer here, but between March and May, and then between September, October, and November, December, those are the peaks, and we are probably going to reach 6.5 million next year on that side, and then 80,000 new users every day, meaning people that register to Tinkercad for the first time every day, and that will let us pretty much feel kind of the Beijing Stadium, which is a nice shape, that very Dynamo-able, I would say, that's why I put it there, and one more probably more relatable to US audiences, like a MetLife Stadium in New York. I mean, some of the big arenas here, right? So we could feel one of those every single day with just people that are new on Tinkercad. That's pretty huge. Who uses Tinkercad? It's basically, our target is students that are doing STEAM projects, STEAM education, right? So science, technology, engineering, arts, and mathematics. And our normal target is around middle to end of elementary school into early high school. So for grades 4 or 5 into 9. Before that, you can use it, of course. I mean, we have people in kindergarten using it. And after that too, we have actually people in college and also professionals using it. But this is our sweet spot. I mean, the center of here, right? So, and this is where we are targeting, because at the end of the day, what we think is that once you get into high school and you're starting to make choices around careers on STEAM or engineering, design and stuff, that's where we expect them to start looking into Fusion, Revit, Dynamo, right? Civil, AutoCAD, whatever, right? So I like to think of us as a very wide net, right? That sparks the curiosity of people saying, hey, oh, I can do all these things, right? And maybe more people than the probably 5% from a whole class that will end up in engineering or architecture or sort of related things might say, hey, this is actually a fun path to go. The last trivia here on the next click is that the team is actually 10 people. Right, so 10 people make the application that has the most amount of signings in Autodesk, more than AutoCAD or more than everything together, right? We have 500 million views on TikTok. We have, I mean, any number I put on Tinkercad, it's in millions and millions and millions. And I'm sort of bragging, but it's okay. But let me show you a little bit what it does. So next slide. And again, remember, this is about people getting started, right? So somebody that gets started in Tinkercad is probably a 7-8-year-old kid generally, right? We have, again, all sorts of people. And we always try to make sure, how can we make an experience that is extremely relatable? And to make it relatable, it has to be related to something they do before. And there's not a lot of CAD in their lives at that time, right? So, but what is there? It's logs, bricks, Legos, right? These little wooden blocks that are at least on every single elementary school I've seen in the US at least, right? But we have a lot of, so basically Tinkercad works by aggregation of objects, right? as opposed to thinking in terms of sketches, because sketch is very abstract for this page. So in the next click, if I told you how to build that chair, most of you would probably look into something like this, right? And how to, now, if you click again, this is how a 7-year-old will think it. Why? Because they use Minecraft. Right? Why? Because they don't know these things, right? So we are, I am receiving a generation that was born with an iPad, right? That was that has been playing with maybe Minecraft or stuff like that since they were 3 or 4 on an iPad, right? So they sense space better than before, right? But still, I mean, we need to build some of their skills around abstraction and stuff. So, for example, the way Tinkercad works. Another click. This is just a quick thing, which I'm building a wrench. So again, I'm not making the sketch of a wrench and extruding, because that would be very abstract. I'm just putting a rectangle, a box, making it flat, putting a cylinder, cutting a little piece, and putting another kind of half a cylinder on the side and cutting another piece, and that's it, right? So it's deceptively simple, right? To the point that many people would just say, oh, that's a toy. Let me tell you something. When we looked at Tinkercad for the first time, and it was an acquisition, so it was more like it was a competitor eventually at the beginning, right? The first time I saw it, it was just like, it has 3 commands. This is a toy. A couple hours later, I said, it has 3 commands. A day later, I was like, oh crap, it has 3 commands. And I saw all the things I could be doing with just that, right? So quick click on the next one. So, and of course, I mean, aggregation gets you anywhere, right? Aggregation gets you to building the Barcelona Pavilion. And that's an easy one, I would say, right? But a nice one, because we might have some architects here. But they are also building cars or mechanical designs or characters, or in this case, this amazing T-Rex just based on using a little iPad, right? But we also have electronics, because just building a piece of plastic is not just really what matters today. And by being relevant to us, it also means to be relevant with things that are important for education today. And as you probably have seen that in the last 5 to 6, 7 years, right? Even the big kind of retail stores have started kind of having electronics kits and drones and stuff like that, right? So Tinkercad can simulate and design with microbits, can simulate and design Arduinos, and this line following robot was fully made on Tinkercad, right? So it's not just lighting an LED, right? We can go fairly kind of aggressively into something more professional, but understanding that then there's a Fusion 360 that can actually get a PCB and do auto wiring and do all the other things that we need to do to make a real product. I would not expect a real product to be done on Tinkercad, but it has become a really fast prototyping tool for many people too. Click, please. And since we're talking about code, and the other thing that many of these kids know today is Scratch, right? So we added Scratch blocks, both for programming Arduinos and microbits, and also for programming, kind of doing more like parametric modeling on Tinkercad, right? So I just said parametric modeling in an audience of 7-year-olds. So now imagine how old those kids will be when they're 15 or 20. They're gonna be scary. I don't want to be the teacher at college of those kids, because, oh, let me tell you something. I've seen that 10 years ago. What? Tell me something new, right? So they're going to be a very uncomfortable audience for some teachers. Anyway, and also not only that, because we're just, if for example on the electronic side, not only we show you the blocks, but we also show you how would that look in text. For example, in C++ for or in Python for microbit, right? So we're not meaning here to be a computer science learning application, but we can kind of tell you what's the next step, right? And when I look at Dynamo, so it feels a lot like a next step after this, right? So because this is very linear. I mean, this is great for learning, but has a lot of limitations too. And I'm good with limitations because that can all open the door for the next thing. So the other thing we just added on Tinkercad, two more slides, please, just one more click. And also has to be fun, right? So not that was
There we go. Sorry.
No problem. It has also to be fun, right? So I mean, as a lead of Tinkercad and trying to define the vision of the product, one thing I realized from the very beginning was that at this stage, there has to be a big intersection from what you're getting asked to do at school and your obsessions, right? And if your obsessions are Minecraft or Roblox or Plants vs. Zombies or Legos or whatever brand of highly sophisticated interlocking systems, right? Right. So we wanted to be there too, right? So from any Tinkercad model, you can recreate it with bricks, right? And we worked very close to Lego to do these things, for example, or we do the same for Minecraft, and you can export a schematic. And if you have a Minecraft editor out there, you can import your stuff there. And Minecraft people will say you're cheating because you're not building it there, but who cares? Last click. And this is the latest thing we added, because since this was not enough, we also added simulation for kids. So these are just examples of things that we've seen our audience do, or some of them are examples. But the other day, somebody came up with that pool table. It's just like, really? It's crazy, right? So in any of these examples, what we're seeing here is putting our models into understanding how they behave in real life, right? With a physics engine. And not only that, I mean, if you look at Elvis on the top, and we know our audience, we have to throw stuff at things. We have to throw stuff at things. So that was a first release must have. Right. So yeah, we have a lot of fun on Tinkercad, and but not only fun, because when you define the materials for the simulation, we also tell you what's the friction, restitution, density, all those things. So then, for example, if somebody was, and this is an exercise I've seen that I've tried with many kids, is I'm not going to do it now because it's just an image here, but which of these three cylinders will reach the bottom first? And actually, the answer is the red one if they're all the same material, because it has more acceleration at the beginning, right? Even though there's more distance. But if you start changing the materials, and this material has more friction than say the one in the middle will win. And I have not found any material that makes the green win, but they get pretty close, right? So all of a sudden, you're talking about physics, or on the Galton board on the video that you saw on the bottom left. You can talk about normal distribution, right? And just see it in action, right? So there's a lot on Tinkercad that is not just 3D modeling for 3D printing or 3D modeling for something. It's just, we can talk about a lot of things with Tinkercad. So that takes us to the last slide, which is, let's do a Tinkercad challenge, right? So I made this little wood somewhere in Northern Europe, right? Because they also like very, very pure architecture, very kind of elegant objects, right? Like that one I just made there. And I want to have a more organic kind of facade on it. Doing what I just showed on the right will take a while. I mean, it's absolutely possible, but it's absolutely manual, right? Or I can maybe use a Voronoi or something like that, but it will take forever, right? And all of a sudden, I wonder, Jacob, if you could help me with Dynamo, because I know enough Dynamo to know that that's possible, but can you do something about it?
Yeah, and so that's where I stepped in and I said, let's see what we can do. So first question, anytime somebody wants to do something with Dynamo is, do I have Dynamo for X? So Dynamo for Tinkercad sadly isn't a thing yet. I don't know, maybe make no purchasing decisions. But effectively, we know Dynamo can import SAT, SAB, and SolidDef. Tinkercad exports to OBJ, STL, or GLB. There's no overlap there, right? So the quick answer is sad tuba noise. Womp, womp, right? It's not necessarily going to work easily right off the bat. So what else could we do? How could I go about building an interoperability tool, right? Well, anytime I've been asked to do this, and it's been quite a few times now over the last few years and as a consultant here at Autodesk, there's a process that you have to go through. So you have to decide kind of what you want to import and export to by reviewing the file specs for that particular format and the scope of the data that you want to move over. My preferred source for this is Paul Bork's website, paulbork.net /data formats, right? This has all sorts of great information on all sorts of CAD files that are out there, right? SAT, STL, even image formats like GIFs are up there and stuff like that. So you can get a ton of really great information right there. Ideally, once I have some information on that file format, we want to get a very simple sample. Again, the internet can help for this. Try and find a box that somebody else has written or a simple file format somebody else has. And then I will start to outline the code. What would I have to do to sort of build this kind of a tool, right? So from there, we pick our formats. So our Tinkercad export options, we've got OBJ, which will allow for curves, which is great, but it requires an understanding of a whole bunch of curve formulas that I really did not want to have to deal with. So I sort of put that one on the back burner for the time being. STL, readable, simple file format. You can see an example of it here, right? Where we've got pretty quick and easy. I'm defining a solid. Got a facet normal that's this direction. The outer loop is consisted of these vertices at XYZ location for vertex 1, vertex 2, XYZ, vertex 3, XYZ, and the loop and the facet. That makes a face. I can understand that as a person. I could probably explain that to some of those high schoolers that are learning Tinkercad too, right? But maybe it might get a little bit more complex and I might lose some of that sort of form, right? I can't really do curves and stuff like that. So then that is a sort of something to continue. And then we had our GLB format. That is binary right off the bat, and binary is very difficult to work with right off the bat in terms of file formats because it's not something that I can personally read. So I put that one last kind of in the difficulty matrix. So let's look at that ASCII geometry extraction steps. All right, so we're going to drop the first line because it always says solid at the beginning. We're going to split our string at end facet, and that's going to give us all of our different facets. Then we're going to go ahead and we're going to read line 1 to get the normal of the surface. I don't necessarily need that, but it might be handy. Then we're going to go ahead and take line 2 and just skip it because I don't care about the outer loop. Then I'm going to build vertex 1, build a point by XYZ. Vertex 2, build a point by XYZ, vertex 3, build a point by XYZ, and build a polygon from the loops. Again, my X values are all right there. My Y values are all right there. My Z values are all right there. And then once I have all those surfaces built, I can go ahead and build a solid from those surfaces. So seems simple enough. Let's go ahead and open up a sample STL from Tinkercad editor, and we get this. That is gibberish. I can't work with it. I can't read it. I can't explain it to that high schooler kid or anybody really, right? And yes, that is the technical term. So once again, we have our sad tuba noise. Womp, womp. Not great. Well, if I went back and I checked that STL format off Paul's website, there is also a binary formatted STL. Now, there's no way to know if it's binary format. We call it fuscation. Yes, the code is obfuscated. Nobody else can read it. It's beautiful. But actually, it's just binary formatted, right? So if I read the STL file format, we can actually see binary STLs consist of an 80-byte header line that can be interpreted as a comment string. The following 4 bytes are interpreted as a long integer value to give the total number of faces. And then what follows is a normal 3 vertices for each facet, all set up as 4 floating point numbers, 12 bytes in all for each. So 36 bytes for the 3 vertices gets us a face. All right, so if I drop the first 84 bytes, I don't need to worry about those. I can then split stuff into 50-byte sets. And then for each point, I can sort of build up point 1 from bytes 13 to 24, point 2 from bytes 25 through 36, point 3, bytes 37 to 48, and then build a polygon through my points. Pretty quick, pretty simple. I can start to understand that. If only I could read the previous gibberish. Well, fortunately, Python can step up to the rescue for us. We've touched on Python a few different times now, so we're going to leverage it here because, again, I don't speak binary. Python's struct module does this work for us, right? It'll read our binary data. Each byte is read from the start of the file, and then once it's read, it's just sort of dropped off. So you can just continually read that first series of the items that you want. Struct.unpack allows reading the bytes as integers, floats, strings, etc. You just have to format them correctly. You can go to the Python docs for some great explanation on what each one of those are. I won't bother to go into them here, but the plan. I'm going to build a definition to read a triangle from the binary structure as a surface. right? And that's that first definition that we see right up there. Once I've got that definition, I'm going to read the file in binary format. Open file name RB. RB is the format for read the binary as F. From there, I can read the header just because I want to discard those bytes. I can then read and unpack the triangle count, so I know how many triangles I'm supposed to build. And then for each item in the triangle count, I can use the previous definition to build the triangle. Once I've got all my triangles, I can go ahead and I can build a solid from the surfaces and then return the solid to Dynamo. Looks like that should work. I also have to worry about writing out because after I'm done making this content, I want to be able to send it back to Tinkercad, right? It's a little bit more complex because it's like reading, but backwards. So you can see kind of the code there, but effectively it's the same stuff, right? So it's STL, and STL, because of the format being meshes, it's all triangles. We can't use non-triangulated solids, right? So we had to add some error handling for that right off the bat. I'm highlighting the wrong thing up front, but oh well. After that, our header has to be 80 bytes. So we got to make sure that we account for that. And again, we're always reading that or writing the byte array from the beginning. So we'll start right up front. After the header with the 80 bytes is put in, we can start to append our triangle by taking each face, taking the 3 points, figuring out what the normal is, writing that in, figuring out what point 1 is, writing the XYZ for that, figuring out what point 2 is. I'm doing it in a loop, so it's the exact same thing. XYZ, point 3, XYZ, add the 2 padding characters that happen at the end of every 50-byte string, and that's the entire STL format. We just write the file out and call it a day. So let's have a look at what this looks like in the context of Dynamo. Now, we started with a little bit of Tinkercad to export the STL. We have museuminthewoods.stl. I've gone ahead and pathed to that. I'm going to go ahead and freeze this, and we will preview this bit of geometry, and then I'm going to hit run. So as before, you can see the exact same code that I sort of showed there. Let's go to my geometry preview and zoom extents. Uh-oh, where is it? Did I not hit run? And the joys of the live demo, 1 second. Let's make sure that we're pointing at the right thing here. Sold them to cue the danger music for me, so I'm blaming him. There we go. All right. So you can see that content has been brought in. It's been brought in relative to its origin. It's looking pretty good. There's the file. The one thing with that, geometry.explode, because that STL format is all triangulated, you can see I have a lot of faces. I've got 16 surfaces there, right? And if that was a sort of simpler geometry, we probably would expect a lot less than that. 1, 2, 3, 4, 5, 6. So I went ahead and I built another little bit of Python to basically retriangulate the surface. And I just ran the entire thing, which I did not mean to do. So sorry for the spoiler alert. Oh, nope, at least everything's disabled in terms of the preview. All right, so once it finishes running all of this, it can take a few seconds to do all the work here. But once it finishes, we'll get some data previews here that we can start to talk about, as well as our geometry preview for the original piece. We'll turn that off. Come on, Dynamo.
So Jacob, while you're waiting, we haven't got a single question yet in the chat. So given this is community conversations, we would love questions on what you've seen so far, a bit about Tinkercad or Dynamo or the stuff Jacob's about to go through. So feel free to write something in the chat, or if you're feeling brave today, you can come off chat and talk out loud. And sorry, cue the danger music. I'm a little late on that one.
Yeah, that's all right. All right, so we'll take a quick peek in here just so we can sort of see what this is basically doing. I've got the code commented. We'll get this posted up to the forum so people can come and play with this if they want. But effectively, we're saying for each one of the surfaces, group all our surfaces first by their normal, so that everything that is sort of pointed the same way is grouped together. Then we're going to go ahead and we're going to take one surface out. That's going to be my initial surface. Set no fit to true. And then while no fit is true, we're going to go ahead and we're going to sort of run stuff through. If we find a surface sort of fits, we're going to merge it together to basically get one surface. And then we'll take our surface and basically rebuild it, right? Build a surface by patch by taking the polycurve by join curves from the perimeter curve of every surface in our list of surfaces. And then in the end, return a repaired solid. So you can see we've got this out. If I do geometry.explode on that, we've got 6 faces, which is what I would expect. So we've done our sort of simplification correctly. I've also gone ahead and placed a preview of this data with sort of a translucent color, so we can kind of see what that looks like when we get a little bit further in. From here, I went ahead and said, hey, well, we showed a Verneuil, so let's build a Verneuil. I've set my integer slider to 30. I'm going to build some random UVs on there to get a Verneuil which extends well beyond the limits of our surface. That's the intent with Dynamo's Voronoi pattern. We can then intersect that though with our individual faces to get something that looks a little bit more like what I would probably expect, right? Cracked glass on each and every piece. We'll flatten that list and then remove anything that is not aligned. So we have 222 items here. Back here, we had 224 because we had a few points. After we get rid of our points, it becomes a little bit easier. We can go ahead and place a cuboid at the end of each curve. So we're going to get curve coordinate system at parameter 1 and 0 for every one of those pieces. Create a cuboid at each one of those locations. That's going to look like this. You can see them, they're tiny. And then flatten that list. So we've got sort of a single flat list. The next piece is we're going to take our original curve. We're going to get the coordinate system at parameter 0, get the ZX plane of that parameter system, and then build a rectangle at that location and extrude that rectangle as a solid by the length of the curve. That's going to give us a bunch of stuff like this. And that's starting to look like an actual structural frame instead of just lines, which is good because I can export solids. I can't export lines out to STL. I then go ahead and I pull the edges from the original solid, get the curve geometry, and basically build our initial frame. So you can see that list here. Again, creating the cuboids at the corner and the overall frame for each one of the sides. Now, maybe I might have wanted to filter out a couple of those, but for the purposes of this demo, I'm going to go ahead and leave them in. We'll turn those previews off. Everything gets joined together into one particular flat list of all my different parts and pieces. Build a single solid by unioning all those pieces together. And this is actually the slowest node on Canvas right now by quite a bit. But when you think about it, we've got 702 individual discrete solids that are becoming one solid in the end. So probably makes some sense. Build a mesh using the mesh toolkit, which is why I'm in 2.17 today, which will look like this. Sort of the exact same thing of what we had before. And then we could have used our right binary formatted STL, but I actually didn't have to because the mesh.export meshes is available to export STL format inside of the mesh toolkit package, right? We don't have one to necessarily import it cleanly, but we can export, right? And so we get all that. And then we can send that STL once it's been all assembled back out to Tinkercad and import it in. And that's how we get that previous sort of demo. That we saw the lovely sort of images from. And this can be obviously produced in a different way if I wanted to divide these up into panels, or if I wanted to play with maybe the pattern toolkit to generate a hexagon grid or other sort of shapes on those faces. You can certainly do that as well very quickly and very easily. And now we can send and receive out to Tinkercad and get stuff aligned and work on the rest of our presentation and geometry alignment content from there. All right, so that's everything that we had for the presentation and the live demo. Any questions on anything from the audience?
I put one on the chat I can ask.
Yeah.
Live. So this, I mean, this is great. Can you make a container or some sort of, however you call it, in Dynamo that put all together all the nodes that you use? Because it sounds to me that you get the STL imports, right? You get this thing in, and you always will do the same things, right? You try to create a list based on all the points. That will give you a triangle soup, which is exactly what we provide. And then from triangle soup, we'll try to find all the triangles that are coplanar. So you make a face group out of those, and then you create a surface, a patch based on that. So you get the minimum amount of of surfaces at the end of that operation. That feels like a perfect thing to containerize. So you can just reuse it again without having to go through all that process. So how do you do that? And how do you share it with other people, for example, that might want to do this?
That's a great question. So I actually thought about looking back at this. I thought about building this into that node. And the only reason I didn't is I said, this feels like it might be really useful in other parts of my day-to-day workflow. So I kept the two pieces separately as opposed to doing it as one. But once I'm done, what I could do is I could take that individual node or in the individual nodes, and I could say, let's create a custom node from that. Once that's done, we give it a name, import STL to solid, give it a description, example, and then we give it a category. I'm going to give it Jacob made this live on the fly because I did. So then we can go ahead and we can hit save, and that made that a custom node. Custom node contains invalid inputs and cannot be saved. You get this every time you do that with a custom node that doesn't have the properly named inputs. So we're going to name this as file path. And it is a string. I think that's going to be valid. And the out is going to be a solid. And we've got a bug in Dynamo that has to be addressed still. Sol is aware.
Fixed. Yes.
But yeah, it grabs the wrong name, unfortunately. So when I go back, it's going to sort of, because of the autosave, it saves over the previous demo autosave, which makes things difficult. But I can then take these pieces and package them up into a package that could be distributed through Package Manager to do the exact same piece, right? So we could do this once for the write SAT binary, write SAT text, import SAT, and then rebuild surfaces with reduced triangulation. Could all kind of go into one consistent piece.
It feels like a very, very useful node. And it's not just for Tinkercad. I mean, you could be getting something from Thingiverse or I mean, SketchUp.
Or Fusion.
Produce an STL, right? I mean, so yeah, in Fusion, probably you'll get a step file, which was going to make it better for you to but I mean, somebody wants to not show a lot of the IP sort of the
yeah.
Then at that point, yeah, STL is the best format to break everything into something unmutable. So yeah, I just this is good. So okay, that was my question, because it feels like that node should be there out of the box, by the way.
Well, I was going to say the alternate is to us just make it out of the box. So there is actually an export to STL command inside of Dynamo. So Jacob, if you go into your background preview and you do like file export, there should be export to STL inside of Dynamo. We never had the, you're showing the, yeah. So if you just do file export from the background preview, you should be able to export to STL, which probably does the same job as the node-based workflow. So export model to STL. We don't currently have the import to STL feature. That is a hole that has been in Dynamo forever, but based on this conversation and other things, we probably should look at this because it is a more common file format that is used in other places, like we've just discussed.
Yep.
Yeah. One drawback to this, though, I believe, I didn't play around with it too much. I believe it does the entire model as opposed to just one portion of the geometry. So I would be exporting potentially parts that I wouldn't want to see. Or does it just do the display geometry?
Just the display geometry, it should do.
Okay. Yeah, so I'd have to turn stuff off before I do the export. But Great shout out that that's there.
Exactly, but I did want to say, like, the ability for somebody like Jacob just to make this and distribute it as a package is also a powerful feature. And so, if you want to connect, we're talking about tinkering with interoperability today around Tinkercad and Dynamo specifically that use these file formats. If you're talking about a more esoteric file format that we might not have out of the box, maybe ever, then you can use the same kind of approach, the same kind of workflow to build your own connections between Dynamo and anything that works with any kind of file format, which is part of the sort of theoretical underpinnings of today's session.
Mm. So, and this is me being ignorant at this point, but do you, if you share, where would you share that with other people? For example, is there a Dynamo store or something for custom nodes?
Well, yeah, we have a package manager. So it's essentially, you wrap that up like Jacob showed as a package, and you can distribute that on a package manager for anyone to download. And we are actually doing a little bit of work right now on improving the package authoring experience and the package consumption experience too. So in the release coming to you soon, so Dynamo 2.19, you'll be able to, when you zoom out, see what's a package and what's not a package node, and some other goodies coming in the authoring experience too.
Yeah, my internet is bouncing out, so I've cammed down. If I drop entirely, Sol, you might want to pop open the PowerPoint to finish out here.
Sure thing.
But just to cover that, to get to package manager, we could go into packages and then search for a package, and you can grab all the different content that is up there. This is another web request, so we're gonna hope that this doesn't knock my computer offline with the concurrent use of Zoom, but we'll see here. But yeah, it can take a minute or two to just get stuff sort of pulled in, but once it's there, we can look at all the different stuff that other people have uploaded. There's another test my package kind of content. And then from there, we could search for something like, I don't know, Spring, SPRING. So you can see Dimitar's Spring nodes or generative design. In terms of the generative neighborhoods, we could search for Hogwarts to find my AU session. It was generative_design. That's why I couldn't find it. There we go. But yeah, all the different packages that have been produced by the community for everybody to share have been put up there.
And one quick little shout out is the search experience today is not the best. We are actively working on that right now. So out of the box, it's fixed. We're working on the package experience too. So they should be much more forgiving in the next release.
Cool. Yeah, so we've sort of covered how to go from point A to point B. Any other questions from anybody else? All right, if not, we can go ahead and start our wind down here. Next session is July 6th, Taming the Chaos with a special guest as a ghost. Ollie Green. So really looking forward to that. It's going to be all about sort of management and sort of troubleshooting of complex graphs. After that, we've got Getting on the Same Page, which is kind of all about management of our Dynamo content in terms of packages and graphs and everything else on the 20th. And then August 3rd, Discovering a New environment with a mystery special guest. We'll have to see. So maybe we can do like a unmasking, and it was
reveal.
all along. Yeah, which would be pretty fun.
Yeah, so just to give a little bit of maybe flavor here, the Discovering a New Environment is the first of a three-part series where we're looking to show you how to start building your own zero-touch or C# based nodes, work through how to sort of succeed in that space, and building up to submitting an actual PR to the Dynamo ecosystem that would be viable for us to actually, as a team, introduce into Dynamo itself to improve the overall product. Given that we are open source, we do encourage and love submissions from the community to come in to make Dynamo better.
Cool. All right.
Right. So first and foremost, thank you all for joining today. These are some ways that you can get involved in the community if you are interested in different ways, as well as a link so that you can go and potentially submit your own community conversation if it's something you feel like you would like to start hosting. And then on the other side, we have some of our socials if you want to go ahead and follow us along. And I believe that is everything. So again, thank you all for joining, and I will let Jacob and Saul have the last word.
Awesome. Well, thanks again for everybody, in particular, Guillermo. It was a blast getting to work on this with you. Learned a lot and really enjoyed getting to see kind of what's going on in Tinkercad. I'm probably going to sign up and do a little bit of playing with those physics engine pieces.
Please do. It's free.
Really see that have some a lot of fun with those. So. Cool.
Yeah, I'd also just like to echo that. Thank you, Guillermo. I really appreciate you jumping on board with us and showing us a bit of Tinkercad for this. It's been a pleasure.
Yeah, when you first think you just like, what are we going to do? But then all of a sudden we found really good things to do. So can't imagine that can be more than later.
Yeah. And if anyone in the community wants to play with Tinkercad, please do. Guillermo's there to help you when you run into problems, as I guess a lot of documentation is, and we are on our side on Dynamo too, if you want to try and make connections like Jacob has.
Yeah, we onboard like 7-year-olds in 5 minutes, so hopefully this audience will be good.
Yeah, exactly. Cool. All right, thanks everyone. Appreciate you joining.
Bye all.
Yep.